the snow is coming down on our New England town, and it's been falling all day long. What else is new? What could I do? I wrote a Valley Winter song to play for you.
Hopefully, wherever you are watching this podcast right now, you're nice and warm, despite the frequent snows we've had the past few weeks. This is the first podcast in the organic chemistry packet. Organic chemistry, just to start off, before we even get into this podcast, to give you an idea, organic chemistry basically is the chemistry of biomolecules, fossil fuels, and synthetic molecules. Some synthetic molecules are nylon, Velcro, Kevlar, PVC, and any other plastics. One thing that's interesting about organic chemistry is that in the early stages of chemistry, organic chemistry was thought to be the chemistry that dealt only with molecules that were in living things. And then in 1828, a discovery of the synthesis of urea in a lab, urea, which is a organic molecule that exists in a living thing, a biomolecule, was synthesized in a lab outside of a living organism, and then people started to realize the potential of organic chemistry as a synthetic process. So today, the podcast that we are going to deal with is alkanes. Alkanes, we're going to cover, actually, before I even get into what alkanes are, we're going to cover two learning targets in this. Learning target number 1 in your packet, that is represent the first 10, the first 10 straight chain alkanes through electron dot diagrams, line diagrams, chemical names, and chemical formulas. And then the second target, which is use the general formula CnH2n plus 2 to write the formula for an alkane with any number of carbon atoms. Okay, so the first thing we're going to take a look at actually is how carbon bonds. We've actually talked about this a little bit before when we did dot diagrams. You can see the dot diagram of carbon right here. Carbon is sort of special because it has 4 dots, 4 single dots, which means that it has 4 bonding sites. And when 4 atoms are bonded to carbon, it will have a tetrahedral shape, as you can see in the picture down here. Carbon can also actually form double bonds, which means it has 2 pairs of electrons being shared, and it can form triple bonds, which means there's 3 pairs of electrons being shared. Now, one of the interesting things about carbon is if you get this carbon in a tetrahedral shape, and you have another carbon here, 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 and you get this repeating lattice of carbons, you get the molecule diamond. So one of the most precious items on Earth, diamonds, actually is a very, very simple element. It's really just carbon. So just an interesting side note about carbon. So alkanes they are hydrocarbons, which a hydrocarbon is a compound made only of hydrogen and carbon. An alkane actually is a saturated hydrocarbon, which means that all carbons in the molecule are singly bonded. There are also unsaturated hydrocarbons, but alkanes do not fall into this category. They are hydrocarbons containing carbon-to-carbon multiple bonds, so either double or triple bonds. And then finally, the actual definition of an alkane is a hydrocarbon with the general formula CnH2n minus 2, and these should be subscripts. For some reason, this program likes to have a mind of its own, and it sort of does them however they want. It's very nice. Sense the sarcasm in my voice there, if you can sense anything in my voice at all right now. Okay, so all carbon-to-carbon bonds are single in alkanes. Alright, so formulas of alkanes. We've got molecular formulas, the structural or Lewis diagrams, and then the condensed or extended formulas. And we need the pen for this because we're going to do some drawing here. Let's take blue. We haven't used blue very much when we've done these podcasts. So the molecular formula is something very simple. We're going to do the molecular formula for a pretty simple hydrocarbon known as ethane. It's C2H6. So the molecular formula just tells you how many carbons you have and how many hydrogens you have in the molecule, and that's about it. You have no idea how they're arranged. You just know that there's 2 carbons and 6 hydrogens. Now the structural or Lewis diagram actually shows you how the molecule is arranged. So it's what we learned before, the line diagrams. So we have carbon bonded to another carbon, so there's a single bond there, and then we've got, I'm going to draw all the bonds out first. Remember, carbon has 4 bonds it can have, and these are alkanes, so there's 4 separate atoms for each one. So, like I said, this structural or Lewis diagram actually shows the full structure of this ethane molecule. And then the condensed or the extended, this can be written basically 2 different ways. So instead of writing out all the carbon-hydrogen bonds, we assume we know that the carbon-hydrogen bonds are single bonds and where they are, and we just show the bonds between the carbons. So we have CH3, CH3. That would be called the extended formula right there. And then the condensed is even more condensed than that. We're also assuming that we know there's a bond between the carbons as well. So we don't write any bonds out. We're just saying CH3, CH3, because you can see there's a CH3 right here and there's a CH3 right here. So we're just writing it out. It's similar to the molecular formula, but it does show a little bit more of the structure. So the structural or Lewis diagram is the most complete. The condensed or extended actually shows a general idea of the structure, and then the molecular shows no structure at all. So then the general formula, this is the general molecular formula, so this is molecular, of alkanes is CnH2n minus 2. Now, N is the number of carbons that you have. So for this example, if you have 2 carbons, that means plugging into the formula, 2 times 2 is 4 minus, oops, so this should be a plus. That should be a plus. That's a little mistake. So it's CnH2n plus 2. Alright, so plugging into the formula now, this makes more sense. CnH2n plus 2 gets you 6. Cn, so C3, H2n, 2 times 3 is 6, plus 2, that's 8. So using that same formula, C5 and H2n, 2 times 5, plus 2. So this 2 times 5 is 10. It should be 12. C5H12. See if you can figure this one out on your own. Give it a pause here real quick. C15H, I don't know. You try to figure it out. Pause it. Figure it out. All right, welcome back. Hopefully that was a quick pause. So C15H32. 15 times 2 is 30 plus another 2 makes this 32. All right, so now you know how to figure out the general molecular formula of alkanes. We're going to move on. So naming alkanes. The names for alkanes consist of a root name and the ending ane, ane, like alkane. So an example is methane. So the root is meth. The ending is ane, ane. So here you have a table showing you the root names for the number of carbons. So if you have 1 carbon, an alkane that consists of 1 carbon, then the root you use for the name is meth. If the alkane consists of 2 carbons, the root you use for the name is eth. 3 carbons, the root is prop, and so on and so forth. You can read yourself down the list, but I'll read it for you real quick. Meth, eth, prop, bute, pent, hex, hept, oct, non, and dec. So, butane, we're going to take a look at butane. We're going to try to draw out the molecular formula, the structural formula, and the condensed formula. All right, so get a red pen here. Mix it up a little bit. Butane. Bute means, go to our list here, 4. So C, whoa, what is that? That doesn't look right. Let's erase that. Let's get back to our red pen. Great. C4H2N, 2 times 4 is 8, plus 2, H10. Wonderful. Structural formula now. We're going to draw out the carbon skeleton of this molecule. So We know we have C4s, or sorry, 4 C's, and they're all attached together. Now each carbon can have 4 total bonds. So I'm going to draw in the extra bonds to each of these carbons. And whichever bond is not bonded to another carbon, that becomes a hydrogen for an alkane. It's pretty simple. So we're drawing all our hydrogens. Now notice something about the carbons in the middle. They only have 2 hydrogens on them because 2 of their bonds are going to other carbons. So the carbons on the end have 3 hydrogens. The carbons in the middle only have 2. Alright, so this is a big deal when we get to our condensed formula, because to draw that, we want to write out how many hydrogens are bonded to each carbon. So the first carbon has 3 hydrogens. The second carbon has 2. So C3, CH3, CH2. The third carbon has 2 hydrogens as well, CH2. And the fourth carbon has, again, 3 hydrogens to it. So this is our condensed formula. Here's our structural and our molecular formula. Now, this does say naming, so we might as well practice one where we actually have to name it. This is actually a little bit simpler, so let's take a look at a molecule that is C3H8. What would be the name of this particular molecule? Well, all we have to do is look to see how many carbons there are, and we can look down here at our list, prop. So to name it, we would say prop, and then the ending is ANE. You could do the same thing if you have the structural formula. You just count how many carbons there are, and then that tells you the root of the name, and you just add the ending ANE. Alright, so that concludes our podcast on alkanes. Hopefully all this was relatively clear. If it was not, please write down any questions you have, and remember to bring those to class and work on your practice on this.